This is a Hazelnut cluster dryer, and I am a member of the freshman engineering design team at the University of Wisconsin-Madison who designed it. Over the past decade, several farmers in Wisconsin, Minnesota, and Iowa have begun planting hazelnuts as part of a movement to develop a hazelnut industry in the upper Midwest region of the United States. Hazelnut production in the U.S. is currently largely limited to the Pacific Northwest. Hazelnuts grow in clusters, with each nut surrounded by an involucre or husk. In places like Oregon, farmers wait for the nuts to fully ripen, at which time each nut falls out of its involucre to the ground. They are then swept off the orchard floor with special harvesting equipment. Farmers in the Midwest have been taking a different approach to harvesting. Here, the farmers have been picking the clusters off of shrubs before the nuts fully ripen and fall to the ground. This reduces nut loss due to predation by wildlife and also is felt to be a more food-safe practice since nuts that come in contact with the ground can become mechanisms for the transmission of pathogens they contact while on the ground. To avoid mold growth, clusters that are picked off hazelnut shrubs before the nuts are fully ripe must be immediately dried. One of the best ways to do this is with controlled, low-temperature drying. If drying is too rapid or performed at too high a temperature, there's a possibility that the shells could crack, leaving the kernels inside more susceptible to contamination during storage or future processing. The dryer we designed is capable of drying 30 cubic feet of material at a time. It has 5 trays with bottoms featuring a 1/4-inch hardware cloth. On one side of the tray compartment is an air supply plenum. On the opposite side is an air return plenum. A circulating blower draws air from the return plenum and forces it into the air supply plenum. Circulating air is heated with a 750-watt electric baseboard heater. There are 2 dampers, one in each plenum, that simultaneously open and close. When the dampers are open, air is forced out of the damper in the air supply plenum and drawn into the damper in the air return plenum. Power to these dampers is controlled by a humidity and temperature controller. This controller can be set to open the dampers if the internal temperature gets too high. It can also be used to bring in drier air when the humidity level gets too high. Since our dryer was completed well after hazelnut harvesting season, we tested it using haylage we obtained from the nearby UW-Madison Dairy Cattle Center. It worked fine, giving us a completely dry product overnight. Our design team, shown here, include Ryan Atrilia, Andrew Bird, Adam Hartzheim, Mason Roszewski, Haley Sigworth, Carlos Vigea, Darby Wago, and Anna Jordan. The group received assistance from our instructors, Dr. David Bonhoff and Mr. Cody Habek, from our client, Mr. Scott Sanford, and our student assistant, Morgan Adkins. Supplies for our project were provided by the Biological Systems Engineering Department at the University of Wisconsin-Madison.